Okay, let's start. Okay. Last time we started chapter 4, making decisions. Okay, we learned if structure, if else structure, and last time we also learned the if else if structure. Okay, we learned these different things. So today let's continue from there. Okay, from there. Okay, the if else if statement we learned last time. Basically, you have if else if else if else, right? Have this kind of multiple conditions. So the logic flow of this if else if statement is, so C sharp will first check the first expression. If it is true, C sharp will execute the statements inside this if part, then skip all the remaining part. So otherwise, if the expression is false, so C sharp will move on to the first else part and check the expression after the if, right? This if, this is the expression. Let me see. So if it is true, C sharp will execute the second if part, this part, and skip the remaining statements. Otherwise, C sharp will move on to the next else if expression until if all the previous expressions are false, right? C sharp will go to the last else and execute the statement in the last else, then it's over. That is if else if, okay, the if structure. And this is the example we learned last time. Okay. So basically, you can see that we have a variable grade. Okay, we have a variable grade. And first, the if-else-if statement will check if grade is no less than 90 points, 90%. If that is true, right, C sharp will display the message A, letter A, then all the remaining part, this part will be skipped. Okay. So otherwise, it means if a grade is less than 90, C sharp will check if grade is no less than 80. So this part will be skipped, and C sharp will go there, right? Go the second expression to check if grade is no less than 80. So if that condition is true, then you will see the message B. Okay. Otherwise, C sharp move on to the next one. If grade is above 70. Okay. So you will see a message C if it is true. Otherwise, you go to the next else if. So you see that if grade is up no less than 60, the message will be D. So if all previous expressions are false, it means no more than 90. Let me see. So no more than no less than 90, no less than 80, no less than 70, no less than 60. All these four expressions are false, right? C sharp will move to the last else, which is message F. Okay, this is example of if-else-if structure. So here is one example. Assume that there is a int variable grade and a string variable letter grade. Write an if-else-if statement to set letter grade equal to good if grade is no less than 85. Pass if grade is below 85 but not less than 60, and fail if grade is below 60. So for this example, you can see that I use if-else-if structure. If grade is no less than 85, then you will see letter grade good. So else, if this condition grade is no less than 85 is false. So C sharp move to the next expression. If grade is no less than 60, if that is true, so the letter grade equals pass. Okay. So if the condition grade is no less than 85 and the condition grade is no less than 60, both are false. It means it is below 60, right? So C sharp move to this last else part. Letter grade equals fail. Okay. So I explain all the details of this example because if you are new in computer programming, so you have to be very, very clear about the logic flow of this if-else-if structure, how it works. For example, when you have a number associated with this grade, variable grade, what will be the value of letter grade, right? You have to be very clear when you design, when you use the if structure in your project. Okay, you have to be very clear about it. So this is what we learned last time. Also last time, some of you, let me see, some of you mentioned that, so the notes here is not clear, right? I upload a note on Canvas. So because when I explain that, the note here is not very clear. So I now try to use a very similar example to explain how we calculate, right? How we calculate this, the result of x, y, and z, right? With a little bit different example. So before this if-else if, the if structure, so we have x is 5, y is 3, z is 7, okay? So the condition is if z is greater than 7. So z equals 7, so z is greater than 7 is false, okay? So at first, we can check that the condition is false. And for this if, as we learned last time, so for this if, because we don't have a pair of curly braces, after this if statement, we just have 1, 2, 3 different statements. We don't have a pair of curly braces, so only the first statement, right? Only the first statement will be associated with this if. So it means because this is false, so only this one, right? Only y divided equals y, x divided equals y. So it will be skipped, right? It will be skipped. Okay, it will be skipped. So for the second one, y times equals x, z minus equals x. These two are not associated with the if. They are outside the if structure. So these two, y times equals x, z minus equals x, will be executed anyway. Okay, they will be executed no matter the if condition z is greater than 7 is true or false. It will be executed no matter the condition is true or false. Okay, in this case, so we have, so for y times equals x, right? It is equivalent to y equals y times x, okay? And we have y is 3 and x equals 5, okay? Y equals 3, x equals 5, okay? So y times x is 3 times 5, which is 15. So we calculate y times x, which is 15. They assign 15 to y. So y equals 15, okay? So y equals 15. So then we move on to the next one. This statement is also outside the if structure, so we execute it anyway. So z equals 7, right? And z minus equals x. It is equivalent to execute equals z minus x, okay? We consider z equals z minus x. Z equals 7. X equals 5, right? Z equals 7, x equals 5. So the new value of z equals 7 minus 5, which is 2, okay, which is 2. Then, so therefore, so after we execute these statements, so we have x, the value is the same, equals 5. Y equals 15, z equals 2, okay, z equals 2. So this is the result, okay? So let's change the condition a little bit. So what now we have, okay, now we have, so the condition is equal, okay? The condition is equal. So we learned last time, what we learned last time. So if we want the condition to be z equals 7, z equals 7, right? It means that we want to check if z equals 7. So this using two equal signs are important. Okay, this is a correct operator. If you use only one, this is wrong. Okay, this is wrong. You have to use two. Okay, in order to use it as expression. Okay, expression. z equal 7. So this is a condition we want to check if z equal 7. In this case, z is 7, right? Before this, z is 7. So z equal 7, that condition. Now in this case, it is true. Okay? So because it is true, the first statement x divided equals y will be kept. Okay, it will be kept. So it will be executed anyway. So x divided equals y. It is x equals x divided y. Okay, divided by y. So in this case, x is 5, y is 3. So we have x equals 5 divided by 3. Okay, 5 divided by 3. Now remember that x, y, and z, all three variables are int variables. Okay, are int variables. So because they are int variables, so 5 divided by 3. So basically it is, right, 1.66667 something, right? It's like this. So because x, y, and z are all int variables, so the fractional part, right? The fractional part will be skipped. Okay, it will be skipped. It will be truncated. It's gone. So we have x equals 1. Okay, x equals 1. Okay, x equals 1. Then we move to next one for y times equals x. It is equivalent to consider y equals y times x. Y is still 3. X has been updated to 1, right? Based on the previous statement. So x is 1. So y times x, 3 times 1, now y is 3, right? The value of y equals 3. So the last statement is z minus equals x. So z minus equals x. So that statement is equivalent to z equals z minus x. Z is 7. X, the value of x is 1, right? It has been updated to 1 based on the first statement. So z equals z minus x is 7 minus 1, which is 6. Okay, so z equals 6. Okay. So this time I use a similar example to illustrate. So how you need to be very clear about the logic flow of if. So in this example, we don't have a pair of curly braces, right? We don't have a pair of curly braces. So that's why you have to be very clear in this case, right? In this case, only the first statement after the if will be considered as inside the if structure. The other two, y times equals x, z minus equals x, these two are outside the if structure. Okay, they will be executed. These two statements will be executed no matter the expression z is greater than 7 is true or false. Okay, so this is the example I explained this time because last time it is not very clear of the format. So let's continue with the materials in this chapter. Okay. So the next topic is logical operators. So what is logical operators? The logical AND operator, we have two equal signs, okay, two AND signs. And the logic OR operator, this one, allow you to connect multiple Boolean expressions to create a compound expression. Why we need it? Because for AND and OR, for these two, we can use them to combine multiple expressions in one if. Okay, that is the idea. So in the previous example, you see, for example, this one, right? This example. For each if, so we only have one expression. Okay, for this else if, also one expression, only one expression. But we would like to combine multiple expressions, okay, by using AND, OR, also we have NOT. The logical NOT operator reverses the expression true. It means if the expression is true with the NOT operator, the new value will be false. If the expression returns false with NOT operator, it will give us true. Okay, so this Logical operators are very useful in practice. So you see here we have operator AND. So it means both sub-expression must be true for the compound expression to be true. The second one is OR. One or both sub-expression must be true for the compound expression to be true. The last one is not. So it negates or reverses the value of its opposite one, okay? It reverses the value. So for example, you can see that this one, x is greater than y and a is less than b, okay? A is less than b. For this expression, x is greater than y, a is less than b, this is one compound expression, okay? This is one compound expression. So in order to, let me see. In order to, for this compound expression, this one, to return the true value, okay, the true value. So we have two sub-expressions. The first one is x is greater than y. The second one is a is less than b. In order for this compound expression to return us a true value, both sub-expressions have to be true, okay? X has to be greater than y, and a has to be less than b, okay? If both expressions are true, the compound expression can give us a true value. Okay, that is the idea. If one is true, if the other one is false, then the whole expression will be false, okay? The only case we can have a true value, true return value from this compound expression is that each sub-expression is true, okay? Both are true. This is for AND. For the second one, OR, it means you can see that in this example, we have x equals y, y equals z. So for OR, it means if one of x equal y, or x equal z, okay, if one of them is true, then the whole compound expression can return a true value. So the compound expression can return a false value only when both sub-expressions are false. Okay? Only when x does not equal to y, when x does not equal to z. Then the whole expression will return a false value. So for the last one, x is greater than y for this one. If, for example, if x is 5, y is 3, in this case, x is greater than y, right? Okay, but x is greater than y, that expression is true, but is not. It means the whole expression will be false, okay? Because it will reverse the true value to false. On the other hand, if x is 3, y is 5, then x is greater than y, that expression will be false, okay? But with not operator, so not false will be true, okay? Not will reverse its value to its opposite one. So these three are frequently used logical operators in practice, okay? So here is a table. The logical AND operator takes two operands and that must both be Boolean expressions. The resulting combined expression is true if and only if both operands are true. It means, for example, for two expressions, if so the first one is true, the second one is false, right? True, false is false. Because in order to have a true value, so we need both sub-expressions to be true. Similarly, if the expression 1 is false, expression 2 is true, false plus true will be false. False plus false will also give us false value. When we have true value for the first expression and true value for the second expression, true plus true will give us a true value, okay? That is AND operator. For example, in this case, right, if temperature is less than 20 and minutes is greater than 12, we have a message, so temperature is in the danger zone, okay? So it means that we need two conditions. The first one, the actual temperature is less than 20 degree. The second one, it is minutes is above 12, okay, 12 minutes. If both expressions are true, right, we have the message temperature is in the danger zone. However, if the actual temperature is less than 20, but the minutes, number of minutes is, for example, 5. It is not long enough. It is not greater than 12. In this case, so this compound expression will be true plus false. It is false, okay? So we will not see the message temperature is in the danger zone, okay? You have to be very clear. Why explain this? Because in practice, you can use multiple and or not. Combine everything together, which can give you a very complicated compound expression. In order to make sure that the design of the compound expression is fully correct, okay, is fully correct, you have to be very clear about how it works, okay? So here is one example. Assume that there is an int variable grade and a string variable letter grade. Write an if statement to set letter grade equal to B if grade is below 90, but no less than 80. So in the previous example, right? So here in the if statement example, so we use a multiple expressions with if structure to decide, right? If the grade is less than 90, but no less than 80, so the letter grade will be B. Okay, this is how we use if structure to accomplish this calculation. Okay. So in the new example, so here we just want to use one compound expression to assign letter B if the percentage grade is less than 90, but no less than 80%. You can see that here because we have two sub-expressions, so we use AND logic operator. So this first expression, so grade is less than 90, okay, below 90, but no less than 80. The second expression will be no less than is grade is greater or equal than 80, okay? So we use AND operator. You need to remember that there are two operands, okay? There are two operands for this logic operator. If you use only one, okay, this is an error, okay? This is an error. You have to use two operands for the correct AND operator, okay? So if both expressions are true, then letter grade equals B, okay? For example, if grade equals 70%, okay, 70%. So in this case, grade is less than 90, that is condition is true, okay? But the grade is no less than 80% because grade is equal to 70%. The first expression will be false. False plus true, this is the end, right? False plus true will return false, okay? Because the return value is false, so we will not execute the statements inside this pair of curly braces, okay? It is not letter B, okay? It is not letter B. So when you use this kind of thing in your project, you have to be very clear about how it works, okay? How it works. So the second one, it is an OR operator. The logical OR operator takes two operands that must both be Boolean expressions. The resulting combined expression is false if and only if both operands are false. So you see this is a table. When we have two expressions, so if the first one is true, the second one is false, it is true because it's OR. Well, one of them is true, then the whole expression is true. Okay, true plus false gives us true. Okay, false plus true is true. False plus false is false. True plus true is true. Okay, which is all. So here is one example. So if temperature is less than 20, or in this case, you be careful that we use or temperature is greater than 100, okay? Less than 20 or greater than 100, it is too low or too high. Our temperature is either too low or too high. So we see that message, temperature is in danger zone. So let's see if the value of temperature equals 10, okay? If it is 10, we check. The condition temperature is less than 20, it is true. The condition temperature is greater than 100, it is false. True plus false will return true, okay, for the OR operator. So the whole compound expression is true. We will see the message, temperature is in the danger zone, okay, no problem. So if temperature equals 200 or 110, then you will see that temperature is less than 20, that condition is false in this case. For the second expression, temperature is above 100, that expression is true, okay? False and true, so false plus true is also true, okay? So we go inside, we see the message, temperature is in the danger zone. However, when temperature, the value of temperature equals 50, it equals 50. So 50 less than 20, false. 50 is more than 100, false. False plus false, or it is also false, okay? So in this case, when temperature equals 50, this if structure will be skipped, and we will not see the message, temperature is in the danger zone, okay? So you have to be very clear how it works, okay? So here is one example. Assume that there is a int variable grade. Write an if statement to display the message, it is not a valid grade in a message box if grade is below 10 or above 100, okay? So if it is below 10, so we have a reasonable doubt that this is error. So if it is above 100, it is above the maximum possible grade, so it's error, not sure, okay? So in this case, so from the problem, we can see that there are two conditions. If one of them happens, okay, if one of them happens, there is error. It means it's an OR operator. So we need to use OR operator. So here is answer. If grade is less than 10 or grade is more than 100, so we will see the message, it is not a valid grade. It is not. So you have to be very clear about how you write the expression, okay? Let's assume you make a mistake, okay? Let me copy this. So let's assume we made a mistake, okay? We made a mistake. So we made a mistake by okay, so this is okay, we made a mistake. So the correct one is to use OR operator, but we use an AND. We just made a mistake. We didn't notice that. For example, what will happen? So you will see, okay, let's assume if grade equals 5, okay? If grade equals 5, you see, we go inside this expression. 5 is less than 10. It is true, right? 5 is more than 100, it is false. True plus false. In this case, it is AND, right? So we will see the whole expression will be false, right? For a true plus false, so which means we will not see the message, it is not a valid grade. However, if grade is what? Grade is 50, right? If grade is 50, so 50 less than 10, false. 50 is greater than 100, false, right? False and false, false. So we skip, right? We skip the message. We will not see the message, it is not a valid grade. if grade is 110, okay, in this case, grade is less than 10, false. Grade is more than 100, true, right? False plus true, and it is also false. Okay, it is also false. It means the if structure will be skipped, and we cannot see the message. It is not a valid grade. Okay, it is not a valid grade. So in this case, you can see no matter what is the value of grade, the if structure is always skipped, or will always be skipped. No matter what will be the value of the variable grade. Okay, so it means, so this if structure is always skipped, and there's some problem because when we design this if structure, right? So it will display something based on the value of grade, but because of this small error, the correct one is n, right? But we use or, the correct is or, right? But we use n because of a small error, right? There are some problems, okay? I give you this example. I want to explain the idea, which is in practice, okay? So when you finish your work, so fixing all the syntax errors, for example, you are missing a semicolon, okay? Fixing all the syntax errors is easy. Okay, you just need maybe a couple minutes, 10 minutes to finish all the syntax errors. But it's quite possible that you have some logic error like this one. Okay, you made some small mistake, but there are some logic errors. Okay, it means the application can be wrong, but there are some problems. So you have to be very clear about. So the expression used here. Okay, the expression used here. So the last operator is not. So the exclamation, this one, it is not. So if an expression is true, not means false. If it is false, not means true, okay? For example, in this case, the expression is not temperature is above 100. It means if temperature is 90, 90 is more than 100 is false. Not false is true. It means if temperature is 90, this compound expression will return true value, okay? We will see the message, temperature is below the maximum. On the other hand, if temperature equals 110, okay? 110 is greater than 100, that expression is true. Not true means false, okay? We have false, so the if structure will be skipped. We will not see the message, temperature is below the maximum, okay? So this is how it works, okay? If the expression evaluates to false, then the not operator changes this to true, and the message will be displayed. When it will be displayed. This is one example. Assume that there are a int variable grade and a char variable letter grade. Write an if statement by using the not operator to assign letter A to letter grade. If grade is no less than 92, okay? In this case, we want no less than, so we use less than. Not less than is no less than, right? Not grade is less than 90, so if that is true, okay, if the grade is no less than 92, we see the letter grade equals letter A. Okay. Not, this is not operator. So the next topic is bool variables and flags. Okay, bool variables and flag. A flag is a bool type variable, true or false values, that monitors some condition in a program. So when a condition is true, the flag is set to true. The flag variable can have its value set or changed by various code statements in the program. For example, if average is above 95, it is above 95, we have the highest score equals true. So in this case, you see for high score for this variable, So its value is not a number or a character or a string. Okay, it's a true or false. Only two possible values, true or false. Okay, so we have high score equals true in this case. Later, the flag can be tested to see if it is true. You see in this case, right, because high score, the value of high score is either true or false, okay? It is equivalent to the return value of expression. Because, for example, for this expression, average is above 95, right? This expression will return a true value or a false value, okay? It means, so we will either have a true value or a false value from this expression, okay? So because high score is also a bool type, which is true or false. So we can use high score as the expression. We just use high score as the expression because the value of high score is either true or false, either true or false. So we put the high score here. If it is true, right, we will see the message. That is a high score. If high score, the value of high score is false, we are going to see the message. We'll skip, right, this message and execute next statement. Okay, next statement. So this is one example. Assume there is a flag, good score. If good score is true, display the message, it is a good score, okay? So I mentioned here because good score is a flag, it's a bool variable, true or false. So in this case, so you need to understand that good score can be used as the expression directly. Okay, the expression directly. So we have if good score is true, so we will see the message, it is a good score. If good score is false, so the message will be skipped. So the message will be skipped. Okay. So now we have learned if else, if, and logic operators, bool variables. So the next one is some a little bit advanced technique. How we compare strings. So why we need it? For example, right? So you search, right? I want to search the name of a student. Okay. For example, Michael. The name of the student is Michael. So how can I make sure that so the name on the Excel file equals the name Michael? Michael is a string, M-I-C-H-A-E-L, right? It's a string. So we have some other string on the Excel file. So we would like to compare if these two strings equal to each other, okay? If these two strings equal to each other, okay? So you can use certain relational operators and methods to compare strings. We want to compare strings, okay? So we have a couple of different ways to compare these two different strings. So the first one is, for example, string, we have two names. Name one, name two. So we can, the first method is, so we have two strings, name one and name two. Name one is the name Mary. Name two is the name Mark, okay? Both are strings. So we can use the two equal sign, right? Equal operator to compare if the two names equal to each other. Okay, the two names equal to each other. So in this case, we can use the equal operator, equal sign, right? If name one equal to name two, so we are going to see the message, names are the same, okay? So you need to remember, so the first way to compare the two different strings is to use two equal signs, okay? The equal operator. To see if the two strings will equal to each other, okay, to each other. That is the first method. So for the second method, we have if month not equal to October. It is, we compare the variable and the actual string. So in this example, we want to see if month is not October. For example, it is September, right? September does not equal to October. In this case, not September not equal to October will be true, okay? So we will see the message, month is not October. However, if month equals October, so October equals October, okay? So that not equal will be false. So the message will be skipped, okay? Here you have to be very clear about one thing, which is, so for the if condition, right, for this one, if we have if. Not equal to, right, that is the condition in the, on the slides, okay? However, if the current value of month equals okay, so the first letter is not capital October, then the month does not equal to the capital October, okay, because it's case sensitive, okay, it is case sensitive. So when you use this kind of thing in your code, you have to pay attention to these details, okay, because in this case, this October started with a small o will not equal to the October starting with a capital O. Okay, capital, they are different. Okay, they are different. So what you need to learn from this slide is, for the first method, we compare these two variables directly. Okay. For the second method, you compare the variable with actual string value. Actual string value. So we have a third method. Okay, third method. So we still have two string variables. Name 1 is Mary, name 2 is Mark. And we use the method embedded in C#, Visual C#, which is string.compare, okay? In C#, Visual C#. So this method is already built there. You can use it directly, okay? Use it directly. So for string compare, you need two variables for its input, okay? For the input of this string.compare method, okay? In this case, we have the two inputs, name 1 and name 2, okay? This method, string.compare, will compare these two different strings, name 1 and name 2. So if they equal to each other, this method will return the value 0. Okay, it means if the return value from this method equal to 0, we will see the message names are the same. Okay, otherwise it means if the return value is not 0, so the message will be skipped. Okay, this is the third method to compare two different strings. Okay, in Visual C#, we have an embedded method which is string.compare. Okay, so we can use this method string.compare to compare two different strings. So here is one example. Example 1, if we have two string variables, name 1 and name 2, and a int variable a, if the two strings are the same, set a equals 1. Otherwise, set a equals 0. Okay. So for this example, you need to compare two different strings. Okay, two different strings. So we use the first method, right? First method to compare the two variables directly. Okay, directly. So if name 1 equals name 2, a equals 1. Else a equals 0. Okay, a equals 0. So you can also use the second method, okay, the third method, to compare the two different strings. Okay. So if we want to use the third method, the answer will be, right? Let's see the answer. It will be if okay, if string, right? String will be capital S, okay? Compare capital C, right? string compare name1, name2, right? Equal to 0, right? That is the third method we learned from the slides, okay? Then we have a equals 1, a equals 1, okay? Else, a equals 0. Okay, a equals 0, okay? So this is the answer if we want to use the third method, okay, to compare two different strings. So in the exam, okay, if you have a problem like this, ask you to compare two different strings, you write one, if you can write one of the answers, the answer on the slide, or the answer on my Word file here, okay, this is a different answer. If you can write one of the two answers, it is fully correct. It is fully correct. Okay? Both answers are correct. So this is the new answer, right? We use the string.compare method, okay? So another topic we are going to learn today is preventing data conversion exception with the try-parse method. Try-parse method. So what is that? It is, so when we want to transfer the input, we read from some input area like text box, okay, to some variables like numbers. If the transformation is not successful, it fails. If the transformation process fails, so we need some to use try-parse method to deal with this exception. If we don't deal with that, so your application will crash, okay? It will crash, okay? Which is not ideal. We want to prevent it from happening, okay? And we are going to use try-parse method, okay? So exceptions should be prevented when possible. So you can use the try-parse method to prevent the exceptions caused by users entering invalid data. For example, I have an area which is the price of the product, okay? So we expect the user to type $5, $4, $9.50, right? We expect numeric inputs, okay, numeric inputs. However, the user mistakenly input a letter A, which is not a number. So when we want to transform letter A to a number, then it is not correct. It is not correct. So we want to prevent it from happening with try-parse. So we would like to use the try-parse method. Okay, try-parse method. So you can use the try-parse method to prevent the exceptions caused by users entering invalid data. Okay, rather than use try-catch to handle the exceptions. Last week, right, we learned to use how to use try-catch, okay, try-catch structure to handle the expression last week. Now we have a method to deal with that. So the first one, it is int try-parse, okay, double try-parse, decimal try-parse. What is that? It is, first one, it is, we would like to transform a string to a int number. The second one, double dot try-parse, we want to transform a string variable to double variables. The third one, it is decimal dot try-parse. For this one, we would like to transform a string to a decimal variable or decimal value. Okay. So the general form for these three methods, int dot try-parse, double dot try-parse, decimal dot try-parse. The general form for all of the three methods will be data type, int, double, or decimal dot try-parse. Inside the variable try-parse, we need a string, which can be the text property of a text box control. Then we have a comma. After the comma, we have a keyword out. You see the color of out is blue, right? So we would like to use a keyword out. Out, then we have target variable, okay? The logic behind this statement is, so we would like to transform the string, input string, okay, to the data type, int, double, or decimal, and assign the transformed value to the target variable, If the transformation process transform a string to int, transform a string to double, transform a string to decimal, if the transformation process is false, then we have an exception. Okay, C# will jump out. Okay, jump out. The out keyword specifies target variables as the variable in which the parsed value will be stored. Okay, we will put the transformed value to the target variable. Okay. So more explanation is this. So we have more explanations. It is, so we have data type, can be int, double, or decimal. So try parse is the method, okay? After the try parse method, we have a pair of parentheses. So inside the pair of parentheses, we have the string first. We need to get a string from inputs. For example, we get a string from the text property of a text box control. Okay, text box control. Then with the out keyword, we would like to transform the string variable to the data type and output the value to the target variable. Okay, to the target variable. So this is the logic of the whole process. If the process is successful, so it will return the true value for the whole expression. If the transformation process fails, okay, for example, we read a string, letter A, or a letter, whatever, a string, not a number, from the property of a text box control, the transformation process fails, then the whole expression will return a false value. We return a false value. So this is a try parse example, okay? This is a try parse example, okay? So you see here, at first, we would like int variable number. And if int, we use int dot try parse, okay? Int. So inside this pair of parentheses, so we have input text box dot text. Okay, we have an input text box control. So it's text property. From the text property, we can read a string value. We will read a string value. Then we want to transform the string value to a int number. Okay. Then output the int number to the variable number, because you can see before this if statement, we have declared a variable number. Okay. Output the convert number, transform number to the variable number. Okay. If you see, I put the whole expression. I put the whole try parse method expression as the expression. Okay, not as just a single statement. I use it as the expression of the if statement. Okay, what does it mean? It means this int.tryParse method will either return a true value or a false value. Okay, because it will return a true or a false value, so it can be used as the expression of this if-else structure. Okay, if-else structure. You see, if the transformation process is successful, we go to the if part. Okay, we go to if part here. This approach can be used in place of a try-catch statement when the type of error that may occur can be anticipated. So if the transformation is not successful, it fails, then we will skip the if pair of if curly braces, we will go to the else pair of curly braces here, okay? You see the logic here is similar as the try-catch, right? Try-catch structure we learned last week. For the try-catch structure, so C# will execute the statements in the try part, okay? Normally, if some exceptions, some problems happen when C# are executing, is executing the try part, right? C# will jump out the try part and move to the catch part immediately, okay? Here, the logic is similar. If try parse method, the transformation process is successful, the return value is 1, right? It's true, so we do if part. If the transformation process fails, the try parse method returns a false value, so we do else, okay? It can also, with this kind of structure, we can also deal with exception. For example, a common user error handled here is the failure to enter required numeric data into a text box. If the conversion fails, a default value is 0 is stored in the target variable. Okay, target variable. It means if this transformation process fails, so the value of number equals 0. Okay, otherwise the value of number will equal to the transformed value from the input. Yeah. Okay. So the statements in the if block execute if the conversion is successful. So otherwise, the statements in the else block run. Okay. Otherwise, the statement in the else block run. Okay. So this is the second way we have learned to deal with this kind of input exception. Okay, input exception in your project. So you can use either way, right, to deal with the exception. So this is a try parse method example. So here the user is expected to enter a numeric value in a text box to be used in some calculations later in the program. Okay, you see that we declare a double variable input, declare a variable to hold numeric input value. So we would like test to see if the user input is either null or non-numeric. So we use the try parse method. If double dot try parse, okay, for the try parse method, we have distance text box dot text, okay, distance. We want to output the value to the input double variable. So in this case, if the transformation process is successful, so the input variable, the double variable input, will equal to the transformed value from distance text box dot text property. Okay, you will see that if so the transformation is successful, we do nothing. It's empty, right, inside the if block. Else means if the transformation process fails. If this process fails, so we are going to see the message box dot show a number must be entered to convert. Okay, a number must be entered to convert. Okay? So this is one example to use the try parse method. Okay, try parse method. Okay. So the next topic is input validation. Okay, input validation. For the first one, we would like to see if the inputs are valid, are useful or are valid inputs. Okay, are valid inputs. But for this one, we would like to check if the inputs are usable. It means, for example, if we want to read the month, right? So we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 possibilities. All the numbers are int numbers, okay? Whole numbers, 1 to 12, okay? However, if the user type 13,
13 is not a number among 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 10, 11, 12, right? It's not a good number. It is 13. It is not a month. So in this case, if a month is not a number among 1 to 12, then it is not a valid input, even though it is numeric. There will be no exception. The reading transformation process will be okay. It is okay to transform 13 from the input text box control to a number. But 13 is not a valid month. Okay, in this case, we would do input validation. Okay, input validation. The input validation is the process of inspecting data that has been entered to make sure it is valid before it is used. Okay. For example, for the day of date, okay, date. The day will be a number between 1 to 31, or sometimes 1 to 30, right? Sometimes 1 to 28. It depends on the month. However, if the user types 40 as a day for a date, it's error, it's wrong. Even though it's numeric, it is not correct, right? So in this case, we would like to use input validation to validate if it is usable and tell the user if there is some problem. Okay, if there's some problem. So try-parse methods check if the user enters data, but they do not check the accuracy of the data values entered. So here, to validate the number of hours worked in a week. So if hours is no less than 0 and hours is less or equal than 168, okay? So then we have statements. For example, if hour is 300, too much, it's impossible, right? To work 300 hours per week, okay? So with this kind of method, we can test if a number is good or not. For example, on cameras, right? You see, you have finished multiple quizzes, okay? Finished assignment, okay? When I enter your personal grade, for example, the quiz is 20 points, right? If I type 20,000 by mistake, C# will tell me it's a problem. Okay, C# can tell me it's a problem. It means it's numeric, but it is not a valid input. Okay, it's not a valid input. Okay. Also, in the second example, to limit data to an integer range of 0 to 100, if test score is greater or equal than 0 and, right, we have and test score is less or equal than 100, we do statements, okay? Because, so for test score, it cannot be negative. The minimum value is 0. For example, a student missed exam, right, is 0. There are no minus 10 points, okay? Also, if the full grade, we don't have bonus problem, the full points is 100%, right? In this case, if the input is 110, it's invalid, right? So this kind of structure can be used to validate if the value of the variable is good or not, okay? It is very useful. Why? Because when you generate all the variables, you read the inputs, right? Before you conduct any computation or any analysis, you do want to make sure that all the numbers are good. They are not bad numbers. Because if you have some bad numbers, right, the analysis, the result from the analysis or the result from the computation will be wrong. Okay? This is useful in practice because in practice, before you want to conduct the analysis, you do want to check if all the readings, all the input numbers are good or not. Okay? So this is one example for input validation example. We have a very small application. So we have a label and a test score to validate. And we have a small input area, text box control. And we have a button, right? We have a button. And for the button, we have an event, which is validate button click. Okay, well, it means when we click the button, this event handler validate button click will be activated, okay, executed. So inside this event, we have int test score. You can see that for this variable test score int, it is declared inside this event handler. It means, remember, we have learned this, the scope of this, the life cycle or the scope of this variable will be inside this method. It means when this event handler is done, the variable test score is gone. It will be cleared from the memory. We first declare the int variable test score, then we use int try parse, right? Test score text box text output to test score. So it means if you type numbers inside, okay, it's good. However, if you type letters, strings like a name, okay, then the transformation process will fail, okay, will fail. It means the int.tryParse method will return a fail, right? Not true, false, will be false. So this if will be jumped over. C# will go to the else part. The message test score must be an integer will be displayed, okay? If you type an integer, so C# will do this transformation, okay? It is successful. The value will be assigned to the variable test score, okay? So C# will go inside this if structure and C# see a second if structure, okay? So if test score is no less than 0 and test score is no greater than 100, no more than 100, then in this case, so this if condition is true. This is compound condition with AND, right? So we will see the message, the test score entered is acceptable. Else means either test score is less than 0 or test score is above 100, okay? If one of the condition is violated, okay, then C# will skip the second if part, okay, this if part, and try to execute the second else part, okay, which is, so C# will display the message, the test score must be in the range 1 to 100, okay? So you see that this bunch of code can be used to validate if the inputs are good, okay, if the inputs are good, okay? Why it is useful? Because it can prevent the exceptions from happening. Also, it can check if the input numbers are valid, okay? And based on this structure, if something wrong happens, C# can tell the user what's the problem. You can see the message, the displayed message are very clear, right? For the first one, the message is the test score must be integer. Then the user can see the problem immediately. For the second message, the test score entered is the test score must be in the range 0 to 100, right? So the C#, the user can see what's the problem immediately, okay? This is a very useful structure, okay? It's very useful structure. So here is one example. So we have a decimal variable level. If level is between 0 and 10, display the message, it is a valid level, okay? So in this case, there are two conditions. So first one, it is no less than 0. Second one, it is no greater than 10, right? So you need to understand. So here is the example is to validate if the input number is between 0 and 10, okay? So level is greater or equal to 0 and level is less or equal than 10, right? We have the two sub expressions for this compound expression, okay? Compound expression. So if both conditions are true, we will see the message, it is a valid level. Okay, this is a valid level, okay?